Alright, hello math fans. This lesson is actually to derive. So right here. We're going to derive on the product, quotient, and power theorems. And this is for polar form. Okay, so we derive product, quotient, and power theorems for polar form. Okay, so let's start out with deriving the product theorem. Okay, right, nice and small, math fans, because this is kind of going to take up a little bit of room here. So we're going to start off. We have R1 times cosine of theta 1 plus I sine of theta 1 times R2 cosine of theta 2 plus I sine of theta 2. Alright, so basically what we're going to do is we can just pull the R1 and the R2. It's like really factoring them out, or really just pulling them out, right? It's just R1 times R2. So that's equal to R1 times R2. I'll put a little multiplication between there. Okay, and then basically I'm just going to FOIL this out. So it's cosine of theta 1, cosine of theta 2, and then outside plus, I'm going to put the I first, cosine of theta 1, sine of theta 2, inside plus I sine of theta 1, cosine of theta 2, and then last plus I squared sine of theta 1, sine of theta 2. Whew, just made it. Okay? So that looks really evil and nasty. But what I'd like to do is, well, first of all, we get this I squared here. So I'm going to change that I squared into negative 1. And let's put these guys together right here. And then we'll put these guys together here. So I can simplify that. So let's do that. R1 times R2, and it's going to be cosine of theta 1, cosine of theta 2, and then it's going to be minus sine of theta 1, sine of theta 2. Alright, and then it's going to be plus I cosine of theta 1 sine of theta 2 plus I sine of theta 1 cosine of theta 2. Okay, so we kind of grouped a little bit together. And if you guys can recognize this guy right here, that is actually the cosine sum, right? Remember, that's cosine of A plus B. Cosine A, cosine B, and then its opposite sign, minus sine A, sine B. So I can rewrite this now, R1 times R2, and that's times cosine of A plus B, or cosine of theta 1 plus theta 2. Okay, that was kind of nice. And then if you recognize this guy right here, well, ignoring the I, because I can factor an I out of there, I have cosine theta 1, sine theta 2, and sine theta 1, cosine theta 2. That's actually the sine sum, right? It's plus, right? That's cosine A, sine B, plus sine A, cosine B. And so I can rewrite that as plus, and then again I'm going to factor that I out, sine of A plus B, or theta 1 plus theta 2. Okay, so that's actually derivation for product. And then of course I can just write this if I want to simplify it, R1 times R2, and that is just cis theta 1 plus theta 2. So the deal is, just to kind of summarize this, if you are multiplying these together, you multiply the r's together and you add, so this is, you multiply here and you add the angles together. Okay? So that's kind of nice. That's the product theorem. Alright, so let's do the quotient theorem. So, alright, so we'll set up the same way. R1 times cosine theta 1 plus I sine of theta 1 over R2 cosine of theta 2 plus I sine of theta 2. So in order to simplify this, because we have an imaginary value in the bottom, which is you're not allowed to have a radical in the denominator, so we'll multiply by its conjugate. So it's just going to be times cosine of theta 2 minus I sine of theta 2. Alright, so conjugate of the bottom there, and then cosine theta 2 minus I sine of theta 2. So multiply the top and the bottom by the conjugate of the bottom, and we get on top, it's a little large, so again, write nice and small, R1 times cosine of theta 1 cosine of theta 2 minus cosine of theta 1. We'll put that I in front again. I cosine theta 1 sine of theta 2 plus I sine of theta 1 cosine of theta 2 minus I squared sine of theta 1 sine of theta 2. Okay, so that whole thing, and that's all over. If I multiply that out, I get R2, and right, just because the conjugate, when I do FOIL, the outside and the inside, they cancel out, and I just have to do the first, which is cosine squared of theta 2, and then the last, which is minus I squared of sine squared of theta 2. Okay? And then a couple things to recognize here. Well, actually, just so we don't have to write this whole thing over again, actually, let's do that. Let's write the whole thing over again. So just because we need to kind of group a couple things. So kind of like when we did product, we're going to group a few things here. We're going to group cosine of theta 1, cosine of theta 2, and this guy right here, this minus I squared sine theta 1 theta 2. Of course, I squared is negative 1, so it's really plus sine of theta 1 sine of theta 2. And then we'll just do the rest of the stuff here. Plus, and we'll do, at least it doesn't matter, but we'll do this one first. We'll do this guy. So plus I sine of theta 1 cosine of theta 2 minus I cosine of theta 1 sine of theta 2. Okay, and that's all over R2, and then we have just cosine squared of theta 2, and then again it's minus I squared, so it's going to be plus, because two negatives give you a positive, plus and there should, yeah, plus sine squared of theta 2. Okay? Now, a couple things you recognize right away. If I look at the top, okay, the top is our difference for cosine, right? Cosine A, cosine B, plus sine A, sine B, and so we can rewrite this as R1 times, and we'll put this in brackets here, so we can use parentheses. So this will be cosine of theta 1 minus theta 2, because it's difference, cosine difference, and then it's plus, so that was the first part right here. Okay, and then if you look at this guy right here, you should recognize that as sine difference, right? Sine A, cosine B minus cosine A, sine B. So that's going to be plus, oops, not there, plus sine of theta 1 minus theta 2. And that's all over. And let's see, the bottom here, this guy right here. What is that equal to? Cosine squared plus sine squared? That's just 1. So that's nice, cancels out. You just get R2 on the bottom. So if I can rewrite this whole thing here, it's basically, here it's all here. It's R1 over R2 times cosine of theta 1 minus theta 2 plus sine of theta 1 minus theta 2. All right, so the difference between this and the product is obviously you have R1 divided by R2 versus R1 times R2, but now what you do is you subtract the angles when you have division. Okay, so multiplication, you add the angles, and in division, you subtract the angles. So I can actually simplify this R1 over R2 times cis theta 1 minus theta 2. All right, that's really the simplified form for quotient. All right, looks pretty reasonable. The last one I want to do is called the power, or using powers. So this is the power property. Person who developed this, pretty brilliant person. It's Demas, D-E-M-O-I-V-R-E-S. Looks like Demavros, okay, but it's Demas if you want to sound intelligent and speak French. So this is called Demas Theorem. All right, so let's derive this guy. Actually, what we're going to do is we're going to use the product theorem to derive Demas theorem, because a power is just saying, like if I said x to the 5th power, it's like saying x times x times x times x times x. Okay, so it's just x, five of those x's multiplied to each other. So this is the way it starts out here. We have r times cosine of theta plus I sine of theta, and that's to the nth power. So to develop this, let's actually use the product theorem and start off with doing this. R times cosine of theta plus I sine of theta squared. Let's kind of see what happens when you just do squared. So let's write it out. It's R cosine theta plus I sine of theta, and that's times R cosine theta plus I sine of theta. Now these thetas are the same. So it's using the product theorem. It's R times R, so we're going to get R squared. And then that's going to be times, right? What do we do with the thetas? We add them together, right? That's what the product theorem is. So it's really going to be cosine of theta plus theta plus I sine, same thing, add them together, theta plus theta. All right. I can rewrite that as r squared times cosine of 2 theta plus I sine of 2 theta. That's kind of interesting. Okay, so that's actually what that looks like. It's got the r squared and you got a 2 theta here. That's interesting. Well, let's actually do cube now. So if I did r cosine of theta plus I sine of theta cubed. Well, that just means using this guy right here and doing, so here I derived it already, and then us multiplying it by another r times cosine theta plus I sine of theta. Okay, so again, we're using the product theorem. So we're going to get r squared times r is r cubed. And it's going to be cosine of, right, with multiplication you add the angles, so 2 theta plus theta plus I sine of 2 theta plus theta. So that gives us r cubed times cosine of 3 theta plus I sine of 3 theta. Okay, so you see what's going on here is if it's squared, then it's, of course the r is just squared, but then it's cosine of 2 times that. So it's, you look at the exponent. If it's cubed, it's 3 times that. Alright, so here, so the pattern is basically, if I do, like, if it's to the 4th power, it would be r to the 4th times cosine of 4 theta plus I sine of 4 theta. So here is Demas Theorem. Okay, Demas Theorem is really just the product, using the product, but we're going to write it out as r times cosine theta plus I sine of theta, and that's to the nth power, and that is simply r to the nth power times cosine of n theta plus I sine of n theta. So this guy is really in parentheses here because it's cosine and sine of those. So let's change this into a bracket. And that's your answer. Okay? It's pretty simple. That is Demas Theorem. So remember, product theorem, you add the angles and you multiply the r's. So basically whatever theorem it is, you do that to the r's. So if it's product, you multiply. If it's quotient, divide. And if it's power, you raise that r to the power. And then as far as the angles go, if it's multiply, then you add the angles. If it's divide, you subtract the angles. And if it's raised to a power, then you multiply the power times theta. Okay? So that's the derivation of all three of them. And the other lessons that you see online are basically just using the multiplying and quotient and Demas theorem in various problems. Okay? That's it, math fans. Have a nice day. Goodbye.